All right, hello. This is my Grissom video lecture 2, and um, as you can see, I have the wires set up on the M5. I got ground, and then I have the 3.3 volt, and then I have the SDA and SCL pins hooked up to the VCNL 4040. For the sake of this demonstration, there's not too much going on the actual M5 interface, but I'm going to demonstrate um, all of the code running. So if you would excuse me, I'm going to build the first program. So this program just initializes communication over I squared C bus using a particular frequency, and it's reading in sensor data available, and it's reading it at our particular address. This is similar to what we did, I believe, the last lecture video, where it just outputs the specific address where the data transfer is happening, and it should just take a few more seconds. And this code reads 2 bytes from the register, and then it just runs once. Oh no, what happened? I have that dependency up here. Let me just redo this. I'm sorry. Oh, sorry. Gotta move it to source. My fault. Sorry, Dr. Grissom. That's a silly mistake. Let me build that. Go ahead and build that. Yeah, and it's reading 2 bytes to the address at 0x0C, which is an 8-bit register. Let's hopefully this builds fast. And this code is just basically making sure that the sensor is properly wired and responding before we go ahead and go into the more complex files. So this is like a introductory script, just making sure that we can interact with the sensor. It's taking a bit longer than I thought. Don't know why. Oh, this is taking a long time. Okay, now I'm just gonna upload it, and it should print out the I2C can read at our particular address once this loads up here. And then I'll go ahead and check the serial monitor once this uploads. And it'll output down here. I2C read at a particular address, 0x0186. Okay, great. Let me move this one out of source. And then let me put this one into source. Let me go ahead and build this one while I talk about it. So this one adds the ability to write data to the registers in addition to just reading. from the registers. So it uses our I square C read 8-bit address 16 data. It could read in the 16-bit data, and then the write 8-bit address 16 data writes to the 8-bit register, and then we read the chip ID, the 0x0C, and then it reads the ambient light sensor down here configuration, and then it writes where is it? Where does it write to the ambient light sensor? And then where is it at? Oh yeah, it writes it to the 0x1234 address, and then what this code is basically just going over is it has read and write functionalities. Just they're simple, just to make sure that you could read and write to the registers, and then this is useful for debugging the sensor responses to configuration changes, and this basically just shows how to modify sensor settings. And if I just upload it, we should get some more output. I believe there's 3 addresses, or is that the next one? I'm not sure, but it'll print something out for us where the reads happen. Yep, there were 3 addresses. This is because there's one for the initial, and then one for the read, and one for the write. And then if you move over here, move this into main, this into main source, and this into source. And I'll go ahead and build this. So what this code does is it uses the I squared C class, which is rw.h, and it uses that to get proximity data, and then it also gets ambient light data, and then also white light data. It writes configuration values to up here. This is where the writing happens to the registers, and then it converts the sensor readings into human readable values. And in this file, this is basically a reusable class for handling the communication across different devices, and it chooses the bus speed, and then also it checks all possible addresses for connected devices, and then it registers what is it? The read and write methods, yeah, that we previously had. And then actually in this file is where the implementation of all the functions which were defined in this file, they're all defined here. So this is like the more nitty gritty of how these methods actually work. And it returns different errors, so it's good for debugging errors. And it provides it separates the logic from sensor specific code, which keeps it clean. And if we upload, we should get some readings for each of the sensors. I believe it's like each 1 second delay. So we should get that. on the serial monitor. Just a second here. And there it goes. It's reading the ambient light. If I cover it up, it'll make the white light values change. And then if I uncover my hand, it will go back to normal. And yeah, those are the demo for the Grissom video lecture 2.